Hello everybody. We really getting close now. I think we're, I don't know, a week or two away from EOCs, and so here's our last week of reminding you of a few things. So, first of all, you're going to need to keep this all week. So I do not turn this in. You're going to keep it all week because it's a foldable. Some of you may remember that we did this foldable, but I just figured we'll just do it again. So let's go ahead. We're going to make a three-way fold. We're going to fold that in, and then we're going to fold this over like that. And basically it should say average rate of change on the front. Then when you open it, it's got three ways they can give you the intervals. Then when you open it, it looks like this. So you're folding it three ways. Okay, first of all, let's remember that rate of change is the same thing as slope, okay? So why are they bringing in the word average? Well, they're bringing in the word average because when we move outside of linear equations, the slope is not the same everywhere anymore. So they call it the average rate of change, okay? So now, in order to find the slope, we use the same formulas, but they have to give us the specific interval over which to find the slope. So, how do they give us the interval? Well, in words, they could say between -3 and 5 in words, okay? They could give this interval in inequalities where they write x in the middle and then the small number and then the big number. This means the same thing, between -3 and 5. Okay? And then the new notation that they could use, it's called interval notation. It's like where you have a bracket, and they would have -3, 5. This means the same thing as this and as this. It's telling you what points, technically it's telling you what points am I finding the slope at, where x equals -3 and x equals 5. All right, sorry, I had to pause the video. So where was I? Okay, please understand that this is not an ordered pair. That's the reason why there's these box-like brackets here. This is not an ordered pair. It is telling you what two x values that you're going to use to find the slope. Okay? So the way we're going to do this is we're going to break this up into 2 days. So today we're going to understand how to find average rate of change with graphs and tables. And then the one that you all thought was the hardest, we're going to do equations tomorrow. Okay? Again, make sure you're keeping this. Okay? So I do apologize. The grid lines are really difficult to see here, but unfortunately the printer doesn't do very well. But notice, find the average rate of change over the interval -2, 1. Okay, well y'all, we've got to know that average rate of change means the slope. Y'all, if I picked any two ordered pairs, I would not get the same slope with this because it is not a straight line. Now, if it's a straight line, I would get the same slope no matter which order pairs I took. So we have to use where x is -2 and where x is 1. So that's what that means. So where is x? -2. These are my x values. Here's -2, and we've got to find the curve. It's right there. So there's one of your points, which is -2, 5. So we can write that, -2, 5. Okay, and now I need where x is 1. And remember, this is where x is 1. So right here's the 1, and I've got to find the graph. It's right here. And this is the point 1, -4. So these are my ordered pairs that I should use to find the average rate of change, and we know that's the slope. So hopefully by now we know how to find the slope with 2 points. I use do-do, okay, which is down, up, and I write my big bad bachick structure, which is a division bar with minus signs. So down below the line is -2, up above the line is 5, down below the line is 1, and be careful here, you've got a -4. Okay, so now here we add a line and change the sign. So this is actually a 9, and -2 minus 1 is a -3. So when I divide, I get -3. And keep in mind, what is this? This is my slope between these two specific points. It's my slope over the interval -2 to 1. Okay, and I want to show you that you can actually do this by rising and running. So let's go back and find those 2 points. There's -2,5, and here is 1, -4, and we know that we can rise and run to find the slope. So watch this. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then when I move to the left, that's -1, 2, 3. So rise over run is 9 over -3. So you can rise and run just as easily as you can calculate do by turning these into ordered pairs. Okay, let's do another one. Notice we're using the same graph. Trying to get you used to seeing the different ways they can write this. Find the average rate of change from, notice here they just give you the x values. X equals 1 to x equals 3. Okay, well, we already know that x equals 1 is at 1, -4. And x equals 3, let's find that. Well, that's actually right here on the x-axis. That's 3, 0. And let's do. Finding the slope. Down, up, down, up. When I simplify the top, I get -4. When I simplify the bottom, I get -2. My slope is 2. Notice, y'all, slopes are different here. That's the reason for having to find the average rate of change over a particular interval, because the slopes are not the same everywhere on this graph. Okay, so let's take a look at how we can rise and run on this one at 1 and 3. Okay, so right here is the point at 1, and right here's the point at 3. So let's rise and run. 1, 2, 3, 4, and over 2. 4 over 2 is 2. Okay. Notice they can write it as an inequality between 1 and 4. Okay, so let's find 1 and 4. Okay, well here's 1, where x is 1. That's the ordered pair 1, -4. Write that down. Okay, and then let's find where x is 4 on the graph. So right here is where x is 4, and we've got to trace that up to here. This is the point 4, 5. And now we're finding the slope over this interval. So we're going to do again. Down, up, down, up. So this is -9. This is -3. And this time, notice, a negative divided by a negative is a positive. So the slope over that interval is 3. Look at your different slopes. When you over this side, the slope was negative, and on this side, the slope is positive. Okay? All right. Now, today we're going to do one more. We're going to do this section. Not very hard at all. We know that when things are linear, it doesn't matter which 2 ordered pairs we pick to find the slope. Okay, but things aren't linear here. And if we take a look at this pattern, we'll know that, because if you notice, we're multiplying by 2. Do you all know what type of function you have when you're multiplying by 2? Well, it's an exponential. So all of these different intervals are not going to yield the same slope. Okay, so now how do we do this with the table? Well, notice they're saying where x is 2, these are x values, y'all, where x is 2, and where x is 4. So see, what you're going to do is you're going to find those ordered pairs in the table. So right here, we got the ordered pair 212. And where x is 4 is the ordered pair 448. And now we're going to do down, up, down, up. Let's see. I think that's negative 36. I'm trying to do this without a calculator. That's going to be a negative 2. This is going to be a positive 18 for our slope over the interval where x is 2 to x is 4. All right, find the average rate of change between where x is 1 and x is 3. Okay, so now we're going to use this ordered pair, the ordered pair 1, 6. And where x is 3, the ordered pair 3, 24. So we're going to do the big bad bachick structure. Down, up, down, up. I think this is going to be negative 18 if I'm not mistaken. Let's see. Yep. And then this is going to be negative 2. So I get a slope of 9. Notice these are not the same. If this was linear, the intervals that you chose, the slopes would be the same everywhere. Because with linear, the slopes are constant. The slopes are the same everywhere. So maybe we should just write that. Linear models slope is the same everywhere. I.e., that's called a constant rate or a constant slope. So y'all, I think you know from last week, when we start hearing constant rate, that means your slope is the same no matter what interval it is, and that's a linear model. Okay. All right. Let's do this last one. Over 0 to 4. So need the point 0.03. And need 448. All right. So we've got down, up. We've got down, up. That should be, I think, negative 45 maybe. And this is going to be negative 4. And that really won't simplify. We just write 45 over 4. And if you wanted to turn it into a decimal, you could. It wouldn't be a problem. Okay. Also notice this. We should know hopefully by now that this is a quadratic. Take a look at the slope here and the slope here. So we got one of the slopes being negative, and then we've got slopes being positive. So y'all, that's an indicator that you've got a quadratic. You got negative slopes in some places and positive slopes in some places. Okay? All right, now let's take a look at this that we already said we know is exponential. We'll take a look at these. Okay, it doesn't flip over positive, negative, positive, negative. Okay, it actually, wherever we were choosing here, it looks like, you know, we've got a really high slope. That would be the steep part of the exponential, and then these aren't quite, that's not quite so high. But notice it doesn't flip-flop into negative, positive, negative, positive. When you've got negative and positive slopes, that's going to be quadratic, okay? When you've got same signs on your slopes but different, that's going to be exponential. And then when all of your slopes are exactly the same, that's linear, okay? All right, now we're going to save this for tomorrow. So I want you all to keep this with you because you're going to need this week. And now what I want you to do is you're going to do exactly what we did. So you're going to do this sheet where you're finding your average rate of change over these intervals, and then you're letting us know whether it's linear, quadratic, or exponential. So you're going to do that. And then you're going to do this one for a table. Okay? So we're going to do the same thing. Make sure you're simplifying everything as well. Please leave your fractions in simplest form. And you all have a great day.